Hi, this video series is about the hemoglobin problems that pop up throughout chapter 15. So let's start with number 1. Hemoglobin is a protein in red blood cells that carries oxygen from the lungs to body tissues. So just a little introduction there. People with less than 12 grams of hemoglobin per deciliter of blood are anemic. A public health official in Jordan suspects that the mean mu for all children in Jordan is less than 12. So a public health official suspects that the mean is less than 12. He measures a sample of 40 children. Suppose that the simple conditions hold. These are the things that are required in order to do these tests. The 50 children are a simple random sample. I guess that 40 is a typo. So it's 50 children are a simple random sample from all Jordanian children, and the hemoglobin level in this population follows a normal distribution with standard deviation sigma equals 1.6 grams a deciliter. Number 1a, we seek evidence against the claim that mu equals 12. So what is the sampling distribution, x bar, of the many samples of size 50 if in fact mu did equal 12? Make a normal sketch for this distribution. So all we're going to do is we're going to draw a normal curve where mu is 12, just like we were told. So they said mu in fact is 12, and that's our mean. Then we need to calculate our standard deviation. Well, they give us that, 1.6, and so you'd say, well, let's just put 1.6 between here, and then we have 13.6 and 15.2 and so forth. However, we have a sample of size 50, and we know that whenever we have a sample, we need to modify our standard deviation because we're taking the average of many of these, and central limit theorem says that we have to do this. So we take that n equals 50 into account, and we use that, take the square root of it, and take our original thing, 1.6, divided by the square root of 50, and that's going to give us something close to 0.23. So that means our standard deviation is actually, instead of being 1.6, is much smaller than that, so around 0.23. So if we label our normal chart, we're going to have, instead of 12 or 13.6, it's only going to be 12.23, 12.45-ish, something in this ballpark. So this sketch of the normal curve with these markings at the standard deviations is what they're asking for 1A. Let's go on here to 1B. The sample mean was x bar equals 11.3. What they're talking about here, they measured a bunch of kids. They measured the 50 kids, and they got 11.3. Mark this outcome on the sampling distribution. Well, we have our normal graph that we just drew from the last problem, from 1A, and so we need to find 11.3 on here. Well, actually, that's way off to the side. So 11.3 is way over here, almost 3 deviations away. So far away, I didn't even mark it the first time I drew the graph. So 11.3 is way down here. Also mark the outcome x bar equals 11.8 of a different study. So in this other study, they said they got 11.8. 11.8 is pretty close to 11.77 here, so I put that marker in. So you can see one of these is kind of close to the mean, one of these is farther away. Now it asks you to explain. First I'm going to highlight this here. Then it asks you to explain carefully from your sketch why one of these outcomes is good evidence that mu is lower than 12, and why the other outcome is not good evidence. Well, if you see this result here, it's nowhere close to mu equals 12. It's way off, almost 3 standard deviations away. That's pretty good evidence that if this is what you collected, the actual mu probably isn't 12, because 11.3 is nowhere close on this normal curve. 11.8, however, is kind of right in the thick of things. It's not that far away. It's less than 1 standard deviation away from 12. That is not very good evidence that that 12 is not the mean. Because the idea here in this chapter is we pick a mean, let's say 12, and we try to reject it. 11.8 doesn't let us reject 12 very effectively. 11.3, based visually at least, seems to let us reject 12 much better.